In this video, we'll discuss another example of optimization problem. So let's see the problem, right? Let's try to apply calculus to decide what's optimized best or fastest or largest. So some problem, right? And so here we have a ellipse, right? So which is 4x squared plus y squared equal to 4, right? So if you try to sketch the graph here, it's something like this. X is -1 here, and y is -4, 4 here, 1 here. Right, this is our ellipse. We fix one point, which is 1, 0. Then you take an arbitrary point on the ellipse and make a line segment. This is fixed. 1, 0 is fixed. So that's an arbitrary point P here. So as P here is changing, you can see that the length of the green line segment is getting longer, shorter, right? We are looking for a P such that this length is a maximum, right? So in another word, so basically we are looking for find the points on the ellipse that are farthest away from 1, 0. Okay, so that's basically what this problem is asking for, right? You can see that because this is a symmetric shape, there should be 2 points, and we want to identify both points on the blue ellipse such that they are farthest away from 1, 0. Well, let's try to do that. Okay, so let's suppose our point P is x, y, right? So the distance between P and 1, 0, right? Let the distance between P and 1, 0 be what? Be a function. Let's call that d, right? And d equal to square root the difference of x value square plus y square, right? So we want to maximize this function here. And for sure, there's a relation because P is inside our ellipse, right? So there's a relation between x and y, right? And so our goal here is to maximize d given that 4x squared plus y squared equal to 4. Right? So because it's a square root function, there's not much difference between uh, the square root or without square root, right? So we just give a new function, just contain just to be without square root, right? Okay, now we in the same time we can do a substitution because this one here says y squared is 4 minus x 4x squared, right? So let f of x equal to x minus 1 squared plus 4 minus 4x squared, right? So that's basically the distance function without square root. In the same time, to replace y squared by 4 minus 4x squared, right? So we want to maximize f. So let's try to differentiate that. So f prime of x is 2 times x minus 1 minus 8x. So this is negative 2 minus 6x. So you can see that f prime of x equal to 0 when x is negative 1 over 3. Now you can see that, so this is negative 2, 1 plus 3x, right? When x is less than negative 1/3, so this function is, this derivative is positive, right? So which means function is increasing. And when x is greater than 1/3, and the function is decreasing. So f of negative 1/3 is a maximum, right? So f reaches maximum at x equal to negative 1 over 3. Now we are looking for the point, right? So when x equal to negative 1 over 3, y is 4 minus 4 times negative 1 over 3 squared. So this is equal to 4 times 1 minus 9. So this is y squared, right? And 32 over 9. So y here is plus or minus square root 32 over 9. So we have 2 points. So okay. The points either negative 1 over 3, negative square root 32 over 9, and negative 1 over 3, square root 32 over 9 are farthest away from 1, 0. Right? So that's basically one application of another kind of problem, right? You can get maximize or minimize some distance. In this case, we try to maximize some distance. We get a pair of points on this ellipse. These two are farthest away from the fixed point, which is 1, 0.